Oh, hey, how are you? Great to hear. Yeah, come in. Make yourself comfortable. Like a drink? Sure. There you go. Welcome to the Tech Lounge. Shall we begin? Hello again. Welcome to another Tech Lounge. This is another episode where I left the cozy confines of the Tech Lounge and went out wandering to find some fascinating people to speak to. And this episode is 2 more interviews from KubeCon Paris back in March. Feels like a very long time ago now. And it's all about WASM. I speak with Michael Wang and Brooks Townsend from 2 different options, 2 different takes on WASM and Kubernetes. Enjoy. Before we begin, there's just a few people at the door who've got some things they want to tell you. Then we can get stuck in. If you'd rather not hear these interruptions, then please support the show. You can find details in the episode and show notes. What is Second State?
Well, we are the company that started the CNCF project called WASMEdge.
Yep.
So it's a WebAssembly runtime that's specifically optimized for the server-side use case. We started in 2019, to build this project, and later donated this project to CNCF. So we are one of the contributors in the WASMEdge project.
Okay. Let's start with a very, very quick, what is WASM?
You can think of it like a lightweight JVM. So it's a bytecode format that isolates the software from the underlying hardware, that provide abstraction so that the software can run on all the hardware and be virtualized. So it allows attributes that has defined Java and also defined Docker and portability, virtualization, security, and all that. So it's a lightweight virtual machine.
Okay. Yeah. And with Java and with the JVM, you could run all sorts of things. Is WASM a general purpose, or is it more for particular specific purposes?
It's getting to be the general purpose. So Java didn't start as a general purpose either. No. Java started as applet inside the browser, right? WASM, the same thing. Started the browser.
That's a very good point. Yeah. WASM is just like applets that will send people of a certain age into cold sweat.
So 2019, we had a realization that maybe the serverlet moment for WASM comes. So that's why we started this project, right?
So normally, where does WASM run? Why is WASMEdge special? Where does it normally run? It's actually something always I'm a little bit unclear of. WASM is largely designed for the browser, but say prior to something like WASMEdge, was it always just the browser?
No,
it also run on just local machines.
Right. So when it started, it's browser only. That's because it's the problem is to try to solve at the time is to compile C++ code to run in browser safely, right? But like the evolution Java has went through, when that was successful, people start to think maybe I can run it elsewhere as well. I can run it on server, right? It actually has by 2019 there's a very successful use case on the server. It's in the blockchain, because in the blockchain they use it to run smart contract, right? So lightweight execution. So we thought we could do the same, lightweight virtualization for general purpose outside the blockchain in a cloud native environment, right? So at the time we really thought it's going to power microservices and serverless functions. Those are, small applications that you can put them in containers, but it's too heavy for containers. Too heavy for those tasks, right?
It makes it no better than a JVM again. Really.
Yeah, exactly. Well, JVM is another. If you run JVM, you have to wrap in the container again, right? Again, one thing wrap another. So WASM can run as a standalone application in Kubernetes cluster, right? So it becomes much smaller. The application size could be in kilobytes instead of in tens of megabytes, right? So we thought that would be the use case. That has mild success, I think. I think primarily because the way people do microservices and serverless functions has largely been set by 2019. They want to use Go, they want to use, the certain frameworks. And so to say I have a new framework that offers performance benefit, but require you to rewrite application, I think this is a uphill battle. So we had some success, but not blockbuster that we wanted. So then fast forward to last year, I think there's a whole new class of use cases that emerged for WASM, which is to run cross GPU applications.
Okay.
So when you look at the challenge with Kubernetes today is that Kubernetes, even if for Python application, first of all, is very large. PyTorch Docker image is like 4 gigabytes, right? But if you do the cloud native way, write application in Go or Rust and compile, you invariably encounter the problem of different machines have different GPU frameworks, hardware and software. We now have the exact same problem Java had 25 years ago, which is if I develop something on my machine, on a Mac, using the Mac GPU and Metal framework, I cannot deploy it on right? But Kubernetes is not designed to allow you to recompile and restart with applications, right? So we definitely need a new compatibility layer, right? And Java is not that, because Java virtualized the CPU, it doesn't do anything for the GPU, right?
So just to clarify what you said, because maybe this is, I sort of have been experimenting with WASM, and one of the reasons I wanted to talk to you is I have a whole bunch of WASM content planned. So I'm sort of, building a library of projects to profile. So when you talk about things like the cross-platform issues, how is it solving it? Is it that I still have to just build multiple targets, or is something else happening? There's an abstraction happening.
Yes, so there's abstraction happening. That's
the same in the same binary.
In the same binary. Okay. So it's the same way JVM solves the multi-CPU problem,
but much more efficient.
Yeah, because it doesn't need the garbage collector and all that.
I'm trying to how on earth can one binary have like the correct code for Metal, for GL, for DirectX, I don't know, whatever.
So there are no free lunch. So you have to give up something. The thing you give up is it's difficult to do training this way, because training need much lower primitives in a.
Is it comparable to saying? Are you a Mac user?
Yes, I am.
Is it comparable to saying like on the current Apple Macs having an Apple Silicon optimized versus a universal bundle, that kind of thing? It's a little bit bigger in size, or it's not as specific,
It's actually not. It's so in WASM we have API. So so the way it does is that we define a standard API called WASM,
okay.
And have different language SDKs for this API. So developers write applications to this API instead of write to Metal, and they compile to WASM. And when the runtime sees this API call, it delegates to the native framework, runs on that framework.
So it's a little bit like, this is a strange reference, but it reminds me of, when you have like compression standards, it's the interpreter on the decoder knows that how to run that optimized code on the host machine.
So it shifts the work of this from the developers. The developer doesn't need to know which device you want to target. He just needs to know this API. That's what I want to write to, right? Okay. So the person who deploys this needs to make sure that, say if I have a NVIDIA machine, I need to install a NVIDIA driver for those WASM runtime, right?
Okay. Yeah. And so from a developer perspective and experience, how is developing an application to run on WASMEdge different from normal WASM?
So, the WASM is a standard. So all the WASM application runs on WASMEdge. Okay. That's no problem, right? But WASMEdge also evolves faster than the standard, because the standard has to come from real world practice. One of the things we learned from Java is that we cannot have a room of PhDs come up with a standard. And then, that's how the enterprise Java being come along, right? That's, so, at the time I was a big fan of that, because it has an elegant design and all that.
No one knew any better in those days.
So we need to experiment with different ideas in the marketplace. Come standard, right? So I think WASMEdge in CNCF serve that role. So we experimented with a lot of things. So the API I just discussed is being standardized in W3C. Okay. But it's currently, I think WASMEdge is one of the leading ones, because we can translate the API to underlying codes for PyTorch, TensorFlow, Llama CPP and all that.
Because you're not the only option, are you, for running WASM? I think there's also probably Fermion have an option.
So Fermion Cloud, WASM Cloud, they have WASM runtime, and then they have this, native function, like Fermion has Spring, right? So, they have those native functions around it. So WASMEdge sort of has both. Yeah. So, so that's the thing that is not yet standardized.
And there's also like Cosmonic or...
Yeah, Cosmonic is WASM Cloud, right? Which is also a CNCF project. Yes.
Okay.
So, so the good way to think about that is they are more like application servers. Yeah. We are more like JVM.
Yes. That's, And so feeding into that, like what actually, you talked about WASMEdge, but what is second state? What does second state do? And why did you decide to put so much time and effort into WASMEdge? Yeah,
so we started the WASMEdge project, and later, right, it's the reason we started the project is because we see, because I have gone through the whole thing in Java, and, one of my, because I was just out of school, I just got my PhD at the time, and I really want money. So that's the thing, so I joined a very successful company, but took very little equity, right? So the whole thing become very popular, but, I basically just made some salary. And, 20 years later, we see the same thing play out with WASM again.
Yeah.
So we think the servlet moment may have finally come. So we started the project, right?
What would the second state do?
Develop WASMEdge.
That's it. Okay.
And provide services around WASMEdge.
Right. Okay. Anything specific or?
So there are lots of people who want to use WASMEdge, and they would have requirements, that's to be added upstream, right? So of course it's an open project, so they can add it, but a lot of times they don't have developers, so so they pay us to do that, right? So
okay, cool. And KubeCon EU next year or KubeCon NA, whenever that is, what's on the roadmap?
So we're still working. Our two focuses are microservices, serverless functions. That's one, and AI workloads, cross-platform AI workloads. Second. So we are going to marry those two. So to make AI more portable and more accessible in a cloud-native environment, right? So our saying is, because the way that I describe it, you can see this is a complex project because there's a simple interface defining WASM. However, when you dispatch to all those native ones, you have to do integration one by one, right? So there are a lot of people have to work on, say, there's a new framework from app called MLX. That's different from Metal. So how does that translate to the WASM course? So we have, working together with the Linux Foundation internship program. So we have graduate student interns.
The energy program?
Internship.
Oh, internship program. Okay.
It's called LFX mentorship.
Okay.
Yeah. So at any time, we have 4 graduate student interns from all around the world working on those tasks to integrate those, right? So there's lots of things to integrate, and that allows us to work closely with hardware manufacturers, the GPU makers, the tool makers. So for instance, Llama CPP, TensorFlow, PyTorch, and things like that. And so we want to integrate as much as possible to complete the story of truly portability, and also upstream working with Kubernetes distributions like OpenShift, so that they can orchestrate our WASM runtime more efficiently within their cluster.
Yeah. Cool. Awesome. Let's keep it short and sweet. Thank you very much.
All right. Yeah.
Let's start at the top. What is Cosmonic? And then maybe we'll drill down into WASM Cloud.
Okay. Yeah. Could go either way there. So Cosmonic is we're a small startup. We were building an enterprise solution for WebAssembly, for a universal WebAssembly application platform. So people are seeing a lot of pain with running and administering Kubernetes clusters, running and keeping applications updated that run in Kubernetes. They're having a lot of difficulty when they start to think about not just a cloud strategy, but an edge strategy, which that is the very nebulous edge, but deploying anywhere from being in more than one cloud, being in like a co-located region, or smaller devices, depending on if they have a factory floor, if they have something on premises. We're seeing a lot of people have pain doing that with Kubernetes, or spending a lot of money to get that done. So we're trying to solve that problem with WebAssembly and the CNCF project WASM Cloud, which is a soon-to-be incubating project.
Why would WASM solve that problem? Why?
Yeah, so actually I'd love to back up a couple of years. So WASM Cloud came out of the US bank Capital One, so out of the open source arm in 2019, where what we saw was at Capital One, we had tens of thousands of microservices. Over half of them were Java Spring Boot. So when any developer wanted to add value to the business, work on an application, they would go to the cyber team and get a golden approved template for their application, which would come with all kinds of libraries that had been approved. They may be open source, they may be inner source, but something that we have stamped as something that you can use in your application. Now, every single app started that way. And whenever there was a maintenance upgrade or a vulnerability in the application, every application team had to upgrade every single application. So thousands of application development teams and tens of thousands of apps who are doing the exact same thing for the same library. So this originally came out of a thought, well, maybe we can take that common capability, that common dependency, and pull it out of the application and make it available as a part of the platform. And that was how WASM Cloud started. So we were pulling capabilities like HTTP servers, key value stores, secret stores, message brokers, and making that a part of the WASM Cloud platform. Pluggable, of course, so you can extend it on your own. But then each application is just business logic. And what we were looking for is a delivery mechanism for that. And WebAssembly at that time was pretty early stage for the server side, but WebAssembly brought the promise of being a efficient, secure by default sandbox, kind of like a virtual machine. You can write code in a language of your choice, compile the WebAssembly, and then you can deploy that artifact to WASM Cloud and go from there.
And when you say WASM Cloud came out of Capital One, was it their teams or your team that were working on it?
So it was myself and the founders of the WASM Cloud project all worked at Capital One.
Okay.
But it was a project that was open source from the start. And after a year or two of working in that way, we realized that working with common standards for WebAssembly and Cloud Native is the only way to operate. So we applied and donated it to the CNCF.
And WASM Cloud is a way of running WASM. It's probably a better word.
That works.
Not in the browser or on device. It's on the server instead.
Exactly. Yeah. WASM Cloud is, we call it a WebAssembly application platform. Okay. So it's just a binary, but it runs on Linux, Mac, and Windows, the different CPU architectures there.
Okay. I think there's like 3 main server-side WASM runtimes now. Where does WASM, well, that I know of anyway, or that are presented here?
Yeah.
Where does WASM Cloud fit into those 3? What does it offer that's different, et cetera, et cetera?
Yeah. So to be maybe pedantic for a minute, the WebAssembly runtime that we use under the hood is called WASM time, which was it's the standards body, the Bytecode Alliance's reference implementation of the WebAssembly component model. So we use that as our underlying runtime. I totally get what you're asking, where the level that we add on top of just running WASM is the stuff that the capabilities for cloud native applications. So those common HTTP libraries, key value stores, message brokers. We do the orchestration of WebAssembly. So you're able to declaratively express what a WebAssembly application looks like using an open application model manifest. So we're using a common standard there. And we work with a distributed networking service called NATS, which is another CNCF project, to let you run WebAssembly components distributed across any set of cloud edge infrastructure. They communicate together.
So it's less of just a tool that allows a WASM. Is it binary payload? Like what's the best word?
WASM binary works. WASM component. You can say
it's less of just a tool that lets that run on a server, but more of it is actually an orchestration. Hence the cloud, I guess. More than one thing.
Exactly.
And how they all communicate together.
Yep. Yeah. More so. We're very focused on people using WebAssembly as the application component, the actual unit of compute, but we provide the orchestration and the distributed communication there.
And does that orchestration include running some of those other options and bringing them together into the same cohesive orchestration, or do you have to use WASM Cloud on every instance?
So I suppose very technically you wouldn't have to use WASM, but the communication over NATS is really the secret sauce there. And WASM Cloud platform, the WASM Cloud hosts are able to cluster together in a very lightweight, flattened topology way using NATS. So it's dissimilar to Kubernetes. You don't need to have them communicate directly over IPs and all kind of joined together in a cluster. It's really more about the service discovery aspect of it.
Yeah, this is a world that was kind of, I hadn't really heard the term service discovery for a while, because I think it felt like one of those problems that was done, but it isn't really. I think we just got better at it, maybe. It's interesting to hear it mentioned again. Almost to the point where I've forgotten the names of the services that did that. There was like the HashiCorp one.
The way we like to think about it with NATS is with all networking layers, there are many different projects where The networking layer itself is dumb, and the clients are very, very smart, where the applications are doing a lot of the heavy lifting in terms of routing and failover and service discovery, etc. But what we love about NATS is NATS, the network, is very, very smart, and the clients are very dumb, to put it very maybe brusquely. But the thing that we love about that is when people write a WebAssembly component and they run it on WASM Cloud, those components, if they're all running on the same machine, will communicate locally. If you run them on two different machines, virtual or physical, they communicate the exact same using topic or subject-based messaging, but they don't, you never worry about where the components are actually running when it comes to application logic, which is fantastic.
Yeah. And what does Cosmonic add as a service on top of all of this?
Yeah, so Cosmonic does both a hosted platform for WASM Cloud. So if you write your application, you're looking for a cloud to run it out of the box, you can use Cosmonic for that. We also work on enterprise integrations for things like for OAuth, for authentication, for representation of teams and groups, and kind of getting your entire team working in the same logical cluster. We also work on additional projects like we published a Kubernetes operator that allows companies to take their WebAssembly and take it through a GitOps flow. Our main implementation shows through Argo CD, because plenty of people use that. We add on additional mechanisms like a policy server. So similar to an admission controller, you can use things like Open Policy Agent to gate the running of WebAssembly components. So most of what it comes down to, in addition to the very large companies that we work with who really want that WebAssembly advice, how can I best use this? It's really more around the keys to the kingdom way of starting with WASM.
And would you say, Kubernetes, people could argue when you should and shouldn't use it, but it can run fairly broad, generic application.
Yeah.
Application, what the application's doing. Is it the same with, especially with using something like WASM Cloud? I mean, WASM in its more traditional sense has maybe more of a specific use case, but in something like WASM Cloud, is it the same broadness of applications, or is it for very specific types of applications?
It's a great question. I would say the same broadness of specific industries, specific use cases for an application, but that WASM Cloud is very focused on delivering applications. So Kubernetes is really, really great for abstracting the underlying infrastructure away for platforms. And our general opinion is that for a lot of applications, especially if you're just trying to write like a CRUD microservice that takes HTTP, hits a database, that can be very heavyweight to fit into the Kubernetes project, into the scope of that. And many, many people do that. In some cases, it works very well. And in some cases, for just a small amount of actual business logic, you're shipping hundreds and hundreds of megabytes of containers with the Java virtual machine built in.
So you can run a very generic web server CRUD application in WebAssembly? Because I hear sort of contradictory opinions, I think. Or maybe the better statement is you can run it in WASM Cloud. Maybe it's not something you'd run in WASM, but maybe in WASM Cloud, I guess.
Yeah, so we've been working since 2019 to let people run like cloud native type applications in WASM Cloud. And for a long time, essentially, we would say, hey, many applications need to be able to use key value stores and message brokers. So what does that abstraction look like? What's the interface for working with a message broker, to publish and subscribe, for example? And we would implement that as a part of WASM Cloud.
Yeah.
But what we're really involved with now is taking those interfaces and collaborating with other companies, other contributors in the Bytecode Alliance to define specifications like the WASI Cloud proposal, which kind of formalizes that and makes it a WebAssembly systems interface standard instead of you can do that on WASM Cloud.
Yeah.
Because while, of course, we love that you can do that on WASM Cloud, doing that in a common way so that different application WASM platforms can do it the same way. It just gives people greater ability to write an app, run it on WASM Cloud. Oh, it would be better if I use this other project for my app, really. There's no vendor lock-in.
Yeah. Do users find that there's a significant kind of savings of cost and consequently, carbon emissions, et cetera, using transferring an equivalent application from Kubernetes to WASM Cloud because it's much more optimized? Did people know? I mean, cost is probably the one that I noticed more, but
yeah. And there's actually for folks who want to learn about cost, there's a blog post in the CNCF blog from Adobe. They talked about a service they took from running in Kubernetes, and they wrote it for WebAssembly, ran it in WASM Cloud, and it was 10 times cheaper, took a lot less actual CPU and memory usage passively. So there's certainly that correlation. I don't know the hard number, the reduced CO2 emissions of using WebAssembly.
There are some, they definitely exist, but I mean, technically speaking, a lot of the APIs they use are the cost APIs, and they're abstracted. So if you're reducing costs and you're reducing CPU usage and you're reducing memory usage, you're probably reducing carbon emissions too.
Exactly.
Because it's running as a compiled binary, not a bunch of stuff, basically.
And we also, even though we are working at the application level, every single component that you run in WASM Cloud doesn't take any resources passively, any CPU or memory. We spin it up for every single request, handle, and then close it down.
Has anyone, just out of pure interest, this might seem like a stupid question, I have no idea, but has anyone tried to take like the ancillary applications, I don't know, a database, a key value store, and just make that a WASM application? Like, is that even a thing that's possible?
That is a thing that's possible. Okay. People definitely have done it.
Yeah.
What I remember off the top of my head for being the most successful is SQLite compiled to WebAssembly. Makes sense. And that was sense. Yeah, that was very specifically for the browser use case. We've seen it on the server side too. Yeah. It really just depends. When you're running something like a database, something very stateful, then it's something you should approach with care for now, I would say. I mean, I may be narrow-sighted of me. I don't see anybody compiling MySQL to be WebAssembly anytime soon. I can see...
So someone's tried. It really work very well.
People are certainly doing it. People have compiled libc and parts of the Linux kernel to WebAssembly.
Makes a bit more sense, I suppose. Yeah. Okay. And what's on the roadmap for the next sort of 6 to 12 months for WASM Cloud and or Cosmonic, whichever one you feel happier about talking about?
Sure. I'll at least talk about WASM Cloud. Yeah. So we are actually cutting release candidates for our 1.0 for WASM Cloud. We've got a really solid base of WebAssembly standards. We've been operating as a platform for a little over 4 years now. So we're pretty confident in our APIs. It feels great to promise that level of stability. So over the next 6 months, there's many questions and problems we're going to be trying to solve, including being able to make our runtime more embeddable to further and further distributed or smaller IoT devices. There's pluggable security, pluggable secrets management when it comes to contributing to the standards, very into formalizing WASM Cloud. That'll give a very solid base for people to build applications with WebAssembly. And then wherever we can help on the WASM Cloud side with language support, that is a huge driver for people using WebAssembly. And so right now we're working on contributing code to upstream Go and TinyGo. The goal is to have the native support where you can take an existing Go project using all the standard net packages and everything. And instead of go build with a native target, you just go build target WASM, and that speaks the component model.
Awesome. Okay. Thank you very much for your time.
Yeah, thank you so much, Chris.
So that was it. That was our guest today. Thank you very much for joining me in the Tech Lounge. I have been Christian Schiller. If you want to know more about Tech Lounge, head on over to christianschiller.com, or please tell your friends about us. It's quiet and cozy in here, but the more listeners, the merrier. You can find more at christianschiller.com/podcast, or in the show notes or episode notes, wherever you found this podcast. Thank you very much for joining me, and you're most welcome next time.